Steve Crescenzo, President of the Woodturners Guild of North Carolina. It's April 2020, and as all organizations are dealing with right now, we are also dealing with the fallout from COVID-19 and the social distancing requirements mandated by the restrictions currently in place. In order to maintain contact with our memberships, we're going to do a digital or virtual representation of the demonstration that was scheduled for our April meeting, and we hope you enjoy. So in this demo, we're going to talk about a lot of the different ways that you can use a router in conjunction with your lathe to achieve a variety of decorative effects on your wood turning art. We'll be using both a commercial jig made by Paul Howard and a jig that I've made myself for my shop. This is one example of this is just on the rim of this bowl with some stopped grooves that were in here that were done with a router. That's something you couldn't do with a parting tool, and you notice that the inner ring and the outer ring are done with concentric slots cut in. You can also do some things with just a little bud vase here that I cut some grooves in and then filled with acrylic. So using other media to fill in some of the embellishments that you put on there. You can take that and do it on the rim of a bowl, is otherwise somewhat boring poplar bowl that you can also just route some grooves in and put some contrasting woods in there. I think one of the most interesting things you can do with the router is some of this lattice work that is done. It's a combination of cutting grooves starting with grooves on the back, cutting those, and then also embellishing it with additional grooves on the front to get this lattice effect. So that can be done in conjunction with, if you choose to use acrylic filler. This is an example of, again, using the acrylic to fill those grooves in addition to, or you can just leave them blank like that one. Just another piece that was done using that same method. And then finally you can do something like this, where I call this a bread bowl, but it's you're actually through cutting through the body of the bowl, and again, just a very interesting effect with various lattice work. So from a standpoint of resources for this, as I mentioned, I'll be using the Paul Howard jig for much of the demonstration. I'll be using a jig that I developed myself. In addition, I'd like to reference you to John Lucas, a frequent demonstrator in the AAW. In January, wrote an article in the journal, the AAW Journal, that talked about router techniques that he uses on to get his decorations. And so I'm not going to cover what John has covered in here. I've used a lot of his techniques, but you can read this article and learn how he does it, and I'll cover some other options that I also use. In addition, on YouTube, there's a gentleman named William Hunt who uses the Paul Howard jig and has several YouTube videos on how to set it up, use it, and get different effects from it. So I strongly suggest you go to his William Hunt on YouTube and use him as a reference as well. So before we get started, let's just talk about the safety related to these activities. So what we're going to demonstrate here today is a new technique. It's your responsibility to understand the hazards associated with what you're doing. I'm demonstrating it, but it's your responsibility to do it safely. As with any new activity, when you put a router or any other piece of equipment on the lathe has inherent dangers just using it by itself, but then you introduce another piece of equipment in there that has another spinning bit in it, and you do have to be careful with that. Namely, you have, for much of this, the router bit, as you will see, is exposed as we're doing the work. And it's in a position where normally a router is used facing down and the bit is embedded in the wood. At this point, the bit is entering and exiting the wood, and it's exposed. So that certainly is a hazard. You have to be aware of where your hands are relative to the work, and make sure that if it does catch and bounces back, that your hands are not in its path. Obviously, safety glasses, and I recommend using a face shield for any of this. As you'll see in the demo, I've had instances where, particularly when you do the lattice work, there's not a lot holding that together, and it does come apart occasionally, and you want to make sure that you're protected from that. There's a fair amount of dust generated. I will not be running my dust collector while I do this demonstration, mainly from the noise standpoint that it generates, but it is a fine dust, and you should have protect your lungs. And also, it's very loud, and if the combination of the router, the dust collector, and other equipment that you're using, you should have ear protection as you're doing it. And finally, as you do this work, your lathe should be disconnected from the power source, so there's no chance that you will have an accidental start of your lathe. And anytime you're adjusting your router, changing bits, those types of things, make sure you disconnect the router from the outlet as well. So this is the Paul Howard jig, and you can see that it's got a router mounted onto a metal frame, and it can be used in a variety of different configurations. One of the things that I like about it is not only its adjustability, but also the fact that it's self-guided, and it uses these wooden bushings on the front, which you can make in a variety of different shapes, and you can use that to adjust the depth of cut. And therefore, when you do a rounded shape, or something like a hollow vessel that you may want to put some decoration onto, this bushing will just follow the shape of the piece you're routing on. So I like that's very handy. And then this is the setup that you would use for straight fluting, and again, it's adjustable for different size lathes. This is a piece of an adjustment for how much depth you get sticking out, and the other configuration you can use it is you can put it on a rotating base, which then allows the machine to actually rotate radially, and that's how you get the lattice work on the face of a platter, so we'll demonstrate both of those here in a minute. Right, so let's just talk about some regular fluting that we're going to do on a cylinder. Again, something that might result in something like this, or if you're the one that's filled with acrylic, or if you're having it just follow a rough shape that you want to follow, and it'll self-guide itself through that process as well. So one of the important things you need to have in order to do this is you have to have an indexing system. So I'm going to demonstrate two different indexing systems. This lathe has a 48 position indexing system in it, which I will use for this operation. And then later on we'll show an external indexing system if your lathe does not have an indexing system on it. So a couple things you can do here that you can adjust in order to adjust the depth of the cut on this. There's a set screw here that you loosen that allows you to reposition this guide on the front here, and I'm just going to pull this back and make a little bit deeper cut, and you can see right here what it's doing is it's exposing more of the bit here. Alright, once you get that to where you want it, you just tighten that set screw back up, and it locks this mechanism in place. The other thing, so once it's in position, and the bit has to be centered right at the center point of the lathe, so the center point of this bit is right at the center point of the lathe, and it's simply a matter of sliding this back and forth through the motion of the cylinder. Now this could be a long spindle, it could be a baluster for a stairway, it could be a lamp base, whatever you want, but you're just limited by the length of your lathe as to the length of the spindle that you can do. So I'm going to start this on my lathe, and the other thing you have to do, you have to take into consideration, and it's a simple calculation to calculate the depth of your cut and what you want your design to look like, and that gives you your spacing for your flutes as you do it. So One final safety thought is to make sure that your lathe is unplugged as you do this. You certainly don't want your lathe being turned on accidentally as you go through this process. All adjustments to the router and to the lathe should be done before you plug in the router. So that was the first cut, and then what I would do is just, I'm going to go with a 4-unit index on the indexing wheel and readjust that. So that's the process for cutting those, and again you can see that it cuts those at whatever interval you want, and you can make them more or less. And for doing something like this, I would then take this, stick it in a mold, a round mold, pour the acrylic in, and then turn. And as you turn it, you would end just cutting off the ends of these flues as you go along. So that is one method to do it. And just to show you how it guides, how it self-guides, I'm just going to stick this as, again, just a practice piece on a scrap piece of wood. But and I'll just find an area here that I haven't worked on that doesn't have a big knot in it. And really what I want to show you here is how that instead of a straight cut, that the router will actually follow around, follow the profile of this shape you're doing. And I'm going to make this a little bit shallower cut. Again, so you do that by just loosening this, this set screw and then pushing out this guide, so you get less of the bit sticking out. So those are the two that I just cut. And if you wanted to, while you were doing this, if you wanted to be more precise, which you probably should, you can actually put stops on your table that would then stop this as the router went around to the various positions that you want to do. And again, this is just a piece of plywood clamped onto the table that allows you to do this. So that's how you do fluting along the length of a piece. And now we'll talk about something to do on the face of the platter. So now they don't need the tailstock anymore. I can put this larger table on here. It's all this is a sheet of plywood with a couple of clamps for the to hook it onto the lathe bed on the bottom, and I have my indexing attachment on here. So I'm just going to go ahead and fasten this to the lathe, and then we'll move forward with the next step. All right, let's just talk about other indexing systems if you'd like to, if your lathe doesn't have anything built in. So this is an indexing wheel that I've had for a number of years, but there's a number of manufacturers now that make something like this. Paul Howard actually sells one, and this is the indexing pin that actually allows you to pick the indexing holes that you're going to use. So the way this works on this goes, it threads onto there, and then you just take you can either hold it on with a nut, or you can, in this case I'm just going to hold it on with my chuck, and that's going to thread on. You want to make sure that that's locked pretty good in place so it doesn't slip. And then I just have this post on the back that will actually sit into one of the holes on the side. So it's just a matter of threading this attachment in the back into these holes. It's very important that when you do this, that you have an indexing system that it will hold this tight, because if you get any movement at all in this while you're doing it, it's going to make us for a sloppy cut when you do it. So this is set up now, and I'll go ahead and tighten the table down. So this particular indexing wheel has a variety of different, has 3 different hole patterns. It has 72 holes on the middle one. It has 120 holes on the middle ring, and 144 holes on the outer ring, and I actually have those numbers written down there so I remember them. And this attachment here, this post, and in the back side there's just a threaded knob that allows you to turn this in, and it'll pick the hole that you want as you do it, and it'll hold that fairly securely. And I just have this set up right now for the outer ring, which is one I would use most often if I was using this. 48 holes on the indexing on the lathe, 144 holes on the outer ring here. So obviously if I was doing something very fine, I get a lot more finesse with what I want to do here by using the indexing plate rather than the lathe. So I mentioned before about these wooden bushings that you can use. You just make your own as you go along. This one here, if you're doing a smaller pointed profile, allows you to follow a relatively tight curve. You can make them so, as we did with that cove bit, that the bit actually fits down inside of it. You can make those, but again, you can make these in large quantities and just store them and custom fit them for whatever you need. And they just fit in here, and there's a set screw right below here. Just talk about router bits for a minute. These are all, both the routers we're using today have 1/4-inch shanks on them. You really should use carbide and a good quality bit. These are, this particular one is made by Freud, but there are a number of them that are good quality. What we're going to do here is we're going to take and cut these grooves in for these pieces of wood, and essentially we're going to cut a groove and glue this piece of wood into this groove. So you want a right angle groove on the bottom. John Lucas recommends that the way he does it is he uses a flat cutter and rotates the router at 45 degrees in order to get a perfect 90-degree angle at the bottom. Because it's very hard to find a router bit that is a true 90-degree angle on the bit. I found that this Freud bit is very close to, it's as close as I can get to 90 degrees. So I don't rotate the router. I use this 90-degree bit. Actually it's a 45-degree bit, but it's a 90-degree angle at the bottom. And the only downside of this is it's not a very sharp corner at the bottom, but just by a little bit of sanding on your stock that you put in, on your pieces of wood that you put in the bottom, you just knock off that corner just a little bit, and it'll fit in there quite well. You can see that those are fitting in very well. To make my stock to film that. I just run these through the table saw. It's 1/2 by 1/2. And then, because you do want to make sure that you have a good 90-degree angle, I have a stationary disc sander, and I set the table at exactly 90 degrees to the disc, and I run this by the disc sander in order to get 2 good faces with a 90-degree opposing surfaces on them. So I just make these in quantity when I make them, and I just use them or take them as I need them. Alright, so what we're going to do now is go ahead and put the bit in the router. There's a set screw down here at the bottom. You need to make sure you do that in order to get that, to lock that collar in. And then we'll just go ahead and lock that bit in place. And again, once again, we will adjust that exposure on the bit by turning this set screw and just pushing back this collar just a little bit in order to get what we want on there. And we can just pick an arbitrary, this is just a test, so we will and the motion here is that we're going to turn this on and run it through, just run the bit through the face of the bowl. And so you can see we just cut 3 of those grooves. You would then just glue these blanks in here, just clamp them down, and then in the case of this one, I used 2 different walnut and cherry in there. And again, this is just a boring piece of poplar, but you put those the accents in there, and it actually makes it a pleasing bowl. And then once it's glued in there, you'll find that if you just taper the rim a little bit, you can then actually taper. By doing so, you'll end up tapering the size of your blanks. You don't have to actually cut an angled hole or an angled slot in there. If you cut it flat to start with and then taper it down when you're done, you kind of get that arrow shape as you do it. So that's again just a surface treatment on the face of a platter, and now we'll go into doing some of the lattice work. So another way to make lattice work is to actually just make your grooves that penetrate completely through the bowl. In order to do that, you need to have a wide part somewhere on the bowl. Either on this one here it was on the top, but in this one here I lowered it down to support the fingers as you cut them, so you get the effect where on the outside you get a solid groove all the way through, and on the inside you get this rim cut. The sequence to do this is I started out with a rough turn bowl that had been dried. I finished I turned the outside, sanded it, came on the inside, figured out what the wall thickness I wanted here, cut this, cut down through here, And it's very important when you do this that you maintain a consistent thickness because of the wall, at least in the area where you're going to have the grooves cut through, because now the wall thickness becomes visible as you go through. A couple of the design considerations are obviously the spacing and the width of these grooves. And what I found is I prefer the 1/4 inch grooves instead of a wider groove when I do this, because the wider the groove, the more visible the edges are. And if you put a 1/2 inch groove or a 3/8 inch groove in there, for instance, you're going to have to spend a lot more time sanding the edges of that in order to make that, because it's a lot more visible. Plus, if there is any variation in the wall thickness, that'll also be more obvious if with a wider groove. So you can get pretty much the same effect with a narrower groove, I think. So, but that's a design choice that you can make. The other thing to consider is I use a vacuum chuck to finish the foot on all my, or most of my bowls whenever I can. Obviously, you want to make sure that your vacuum chuck is going to fit, not going to intersect where your grooves are, because that will kind of render that useless. So I did think about that. And I also, if you're thinking about something that's going to be a fruit bowl or even something a little bit functional, you want it to have enough strength to stay together. Looking at this after the fact, I probably could have made this rim a little bit smaller, although again, you still have to think about what you need to do in order to make this to have enough wood in there to hold it together. So that's one that's completed. This is just a practice one that I had started. I will tell you, from one of the things you need to consider is I had this off the lathe to look at it, and then I put it back on, and I didn't thread. I tightened the chuck on, but I didn't have it tight. I didn't tighten it on the threads, and when I went in to cut the next groove, it actually, the torque of the router unthreaded it off the spindle, and I ended up with this error here. So again, this is just a practice piece, but those are something to, now I'll be much more aware of when I put it on there, to actually give that a tug and make sure it's tight on the spindle as I go. I guess if you're doing big grooves, you could go through and actually use the set screw on your chuck if you wanted to hold it on there. So we'll go ahead. I'm just going to cut again. This is a practice piece. I had it off the lathe, and but I'll just go ahead and cut it a couple grooves now. So the way the methodology for this is, you figure out the starting point for where you want to put your grooves, and I just put a guide block, or I just screwed this piece of guide on here so I can start at the right point, at this same point every time on every groove. And so all that does, it sets the lathe perpendicular to the bowl at that point. And so the motion is, I'm just going to push this in and then follow this through, keeping the router perpendicular to the bowl as I go along the process here. I have a guide bushing on here, this wooden bushing here, that's going to control my depth, and I wanted about half the thickness of the rim there to come through. But I also noticed that on this bushing, whereas some of the previous ones were flat, this one here has kind of a radius on the front of it, which lets me run it right along the curved surface of the bowl, and it allows me to do it. It's important that, again, as you come around with this, that you keep this perpendicular or tangent to the curve of the bowl as you come around, or else you won't get even cuts as you come around. So we'll do a couple from this view, and then we'll take another shot. We'll move the camera back so you can watch the back of the lathe as we go through. I'm using a cove bit on this just because I like the effect of the radius cut as it comes through here. One of the downsides of using this is that drill bit or router bits do not like to penetrate forward. They're meant to cut on the side. So there is a little bit of, certainly, particularly with cherry, there's a little risk of burning the wood. So you kind of have to make sure you keep the router moving as you come in. If you use one of the spiral flue bits, if you're going to do a flat bottom, that would tend to work itself in. They tend to drill better into the wood, but these cove bits don't. So if you're not careful, you will get some burn marks, which are very difficult to get out. So let's go ahead and move the camera around to the side here, and then we'll try to get a view from what it looks like from the back. All right, so we'll do a couple from this view as well. And again, so the motion is I have a stop on the table here. I just slide this along, and I'm just going to penetrate it into the wood, and then keep the router tangential to the curve of the bowl as we go along. So you can see that that's the motion. So once you're done cutting all these grooves, one of the downsides of this is that there is a lot of sanding involved. And I tried various different ways to sand them, but really just rolling up a piece of hand sandpaper, putting it into the grooves and back and forth is probably the fastest way and the best way to do it. You can use a small file if you have really bad edges, but again, you can see that there's not a lot of tear out in there. It's a pretty clean cut, and it's a very interesting effect. And again, the difference on this one is the grooves come all the way up the sides, with the thick part of the rim is at the top versus the other one we had the thick part on the bottom.